Hello everyone, today we will continue with the section reliable transmission section 2.5. Again, you require to read the corresponding material in your textbook in section 2.5 in order to get a better understanding about the material delivered in class. So if you recall, and at the end of the last class, we talk about the stop and the wait protocol. We mentioned that protocol is very straightforward, right? Basically, the sender will send one frame and then will not send another frame until they receive the ACK or called acknowledgement from the receiver. If the timeout occurs before the receiving the ACK from the receiver, they will retransmit the original frame. This kind of protocol is definitely straightforward, simple, but the problem, the downside is not efficiency. It's not efficient, right? I think near the end of the class, we give this demonstration. Basically, assume you have the networking link has the bandwidth as 1.5 megabit per second, and your RTT, which is the delay, is 45 milliseconds. So basically, the whole capacity of your networking link is 1.5 megabits per second times 45 milliseconds. You can get is 65.5 kilobits. If you divide it by 8, it's about 8 kilobytes. And then we said, right, so basically I want to send one frame at each RTT, right? Because you have to stop and wait. So in that way, if I assume that the frame is 1 kilobits, so in that way, within one RTT, all the bits I send is 1 kilobits. So you can see, in other words, your networking capacity is 8 kilobits, but what you really use is 1 kilobits, right? So that means what? You only use 1/8 of the resources for delivering. So in other words, you do not really fully take advantage of the resources of the networking. So is there some way we can improve this method in order to fully take advantage of this link? And that is the end of last class. The solution is another protocol called the sliding window protocol. This is widely used nowadays. It's really important. You require to really understand that thoroughly. What it means that the main idea is, first I want to give some, the insights, and then we will talk about official definition. The insight here is different from the stop and wait. I will not send one frame and then wait. What I do is I send a multiple frame before I even receive the first ACK. Okay, so let me repeat again. Different from the stop and wait. Basically, I will send one frame and then wait until I receive the ACK and send another frame. Instead of doing that, I will send multiple frames. You can see here is a seeker that here basically means here I have sent multiple frames even before I receive the first ACK associated with the first frame, what we call first packet. By doing so, I can fully take advantage of the link rather than only occupy this link by using one frame. I basically occupy the link by multiple frames. So officially, to mention here is I leave up to n frames unacknowledged at any given time. So basically, in other words, when they receive the first ACK associated with the first frame, the sender already sent up to n+1 frame. Okay, so basically before is the send one frame, before received ACK, now it's a send n frame before receive ACK. Basically, when you receive the first ACK, you already get ready to send n+1 frame. So obviously, right, you basically will take advantage this link with n times compared with stop and wait. So here, so basically, and the idea here is a more detail, right? For example, if I assume I allow to send 3 frames before receive the first ACK. This 3 is called sliding window. So basically, sliding window means the capacity you can send the frames before receive the first ACK. If your sliding window is 3, means you're allowed to send 3 frames before receiving the first ACK. So here you can see, right? I send the first packet, I send the second packet, I send the third packet, and then when I receive the ACK associated with the first packet, I already sent the fourth one. Okay? So again, as I mentioned, this protocol is very important. It's now widely used in the computer networking, so you really need to understand that thoroughly.